This is video A8, still in our logarithms lesson, and we'll begin with problem number 4, a modeling problem. And I think you probably know that means a word problem. Okay, so acidity, how acidic something is, or how basic it is, for those of you who have been in chemistry, is measured in pH. So we'll learn what pH actually means, where pH equals negative log of that. So before we look at that, let's look at the logarithm. Note that it's a common log since I didn't write a base. So this is log base 10, and carefully note the negative here. Okay, so where this symbol is the concentration of free hydrogen ions in moles per liter. All right, so kind of a simple problem. I'm going to give you certain substances and tell you what the concentration of free hydrogen ions is for those substances, and then we have to find the pH, and we'll be using a calculator for this. So let's say that I have lemon juice. And for those of you who don't know, a low pH means that we have an acid. A high pH, and I think they go up to 14, if I'm not mistaken, maybe a little higher perhaps, but a high pH would be a basic thing, and it just right down the middle, I think water has a pH of 7. I think that's all right, but I'm a math teacher. So lemon juice, the concentration of free hydrogen ions is given to us as 0.0063, and we want to find its pH. Now, once again, not a science teacher, but I would have a feeling that this has to do with the hydrogen, and maybe that has to do with parts. Okay, so let's go ahead and do the work. I'll do the work down here. So the pH for lemon juice, so I'm going to make a table a bit, is negative log of that. So now we have to get our calculators out. And I want to remember the negative, and then I have to hit log, and then 0.0063, enter. So quite a low pH. So 2.2, I'll say, and there's the beginning of my table. Okay, let's say that we know that a tomato has a concentration of free hydrogen ions of 0.40316. So we're going to do the same thing. And simply calculator work again. So I have negative log 0.1234 of those, 316, and I get 4.5. If you're getting answers that aren't somewhere around 0 to 14, you're probably doing something incorrect, so go ahead and check your work. Let's do one more of these, and let's say milk. I think these numbers are actually correct. I think I looked them up at one point. So let's say I have 6 zeros here. 1, 2, 3, 4, 5, 6, 2, 5. Doing the same thing. So pH equals negative log. So 6 zeros. 1, 2, 3, 4, 5, 6, 2, 5. Calculator time. So negative log 1, 2, 3, 4, 5, 6, 2, 5. And we get almost the same as water. So about 6.6. One more problem for today. And this is kind of practice with what we did last time. This is problem number 5. Let's try to graph y equals log base 1/3 of x without messing around with its inverse. Let's see if we can graph directly from this. And hopefully you'll start to recognize what logarithmic graphs look like eventually. But for now, we're building that understanding. And so we're going to make a table. And last time I said a lot of students really like to choose the y's. And we'll see if that makes sense in this case. We're going to choose the y values and then try to come up with the x's that would give us these y's. So I'll write that out right here. So 0 equals log base 1/3 of x. This means 1/3 to the 0 is what? Well, 1/3 to the 0 is 1. This means 1 equals log base 1/3 of x, which in exponential form means 1/3 to the first is x, so 1/3. Okay, here, and I think I'm seeing the pattern. Here I have 1/3 squared, which is 1/9. So it looks like I'm multiplying by 1/3 as I increase the y value. That means as I go this way, I must be dividing by 1/3, which means also multiplying by 3. And let's see if that continues. So -1 equals 1 log base 1/3 of x. So 1/3 to the negative first. Remember, a negative exponent, we flip it. Flip the 1/3 and I get 3, and we did multiply by 3 again. So we should be able to guess what this is. 1/3 to the negative second. Flip it and we get 3 squared, or 9. All right, so now when I start my graph over here, I'm going to look at the x's I need and the y's I want. So the y's look like they can be whatever, go up and down, but the x's are getting really close to 0 here. We probably have an asymptote again, but they go way up pretty steeply over here. So let's go ahead and see what this looks like when we graph it. So I really don't need negative x values, but I'm going to make 9 over here. So each of these is 1. Okay, here I'm just going up normally. So here I have x and y. Plot our points. So 1, 0. That seems like a point that might be common to our log graphs. We'll see that as we go on. 3, -1. So 3, -1. 9, -2. 1/3, 1. 1/9, 2. I'm going to rotate this so I can graph it more accurately. And there we have a graph, and it does look similar to log graphs that we've seen. Okay, your homework tonight